Topic 2, pesticides. This is from topic 2 of our Science Focus 9 textbook. A pesticide is designed to affect only one type of pest. Its use is now pretty common worldwide to increase the growth of commercial crops by controlling different types of pests. So we can use herbicides to kill weeds and unwanted plants, herb being plants. Insecticides kill insects and bugs, clearly from its name. And fungicides control molds, fungus, and different growths, so diseases. Mosquitoes are a really common example that we'll use to talk about pesticides. So citronella candles, mosquito coils, or DEET, which is found within mosquito sprays, can keep mosquitoes away. This is not considered a pesticide. A DDT, which is a pesticide, actually kills them. So kind of different in that this one just keeps insects away. This one will actually kill. This one is an insecticide. So which is better, and does it depend on the situation? Well, of course, it'd be really, really nice to kill all the mosquitoes in the world and we'd never have to deal with them again. However, bats and other living organisms feed on insects, and insects also help to control populations of other things. So it's really important that we actually maintain some number of insects in the world, unfortunately. So killing all of them wouldn't be helpful. However, there are situations maybe that we do want to kill bugs. Maybe bugs that are carrying disease. They might need to go. It's really a big open-ended conversation about these kinds of things. So let's talk about DDT. DDT was originally thought to be directed only at the insects it was intended for. The invention of DDT was seen as a breakthrough in medicine. It was really important because typhus, which was transmitted by lice, was rampant during World War II. So they used DDT to kill the bugs that were carrying typhus, as well as anything else around. But it also helped to kill bugs carrying malaria. So it was super effective, and the guy that designed it was awarded a Nobel Prize. However, what they found is that DDT is a persistent pesticide. It stays in the environment for a really long time. So although it was very helpful in controlling disease that was killing people, we also needed to start thinking about the after effects. So I've linked this video underneath this one on our course website, just so you can take a look at it. It talks about DDT, its use, and when they figured out that it wasn't maybe the most helpful. Biomagnification is when a chemical moves through the food chain, the concentration of that chemical increases. So for instance, DDT can be magnified through the food chain. So can mercury. So if we have mercury in the water, the plankton living in the water get a little bit of mercury in their body. Aquatic insects eat the plankton, so they take on a little bit of mercury. And because it's persistent, it doesn't leave their systems. Now, aquatic insects don't just eat one plankton, so they take on more mercury than one plankton had itself. So aquatic insects start to build up a little bit more mercury. This continues when insect-eating fish eat those insects. The insects had more mercury, you can see here, than the plankton did. And because insect-eating fish don't just eat one bug, they eat multiple, they take on more mercury. Fish-eating fish take on more mercury. And of course, when we catch fish, we take on more mercury because we don't necessarily just eat one fish. So this is important to consider, that as we go up the food chain, the concentration of a chemical that is persistent or biomagnified will increase. So things like DDT, back to DDT, our example here. They've developed and tested some other compounds. None are as effective or safe or as low cost as DDT, because DDT, if you haven't watched this video before, has been banned in some countries. Pests are becoming resistant to pesticides as well. This is because of natural selection. Pests that can have a gene, maybe mutation, that doesn't allow DDT to affect them live, whereas other ones don't. And then those ones who have lived reproduce, passing along their gene mutation. Many pesticides have also been controlled or banned by governing bodies, like DDT. So research and development continues for new and safer pesticides that break down faster in the environment. Again, we don't want something that is persistent. We would like something to do its job and then break down right away. Some practice: complete the learning guide for topic 2, which is pesticides. This will be helpful if you watch that little video I've referenced and linked. As well, you are going to be asked to do an investigation in your textbook. So make sure that you either have a textbook or download topic 2 in environmental chemistry from our course website to look at.